I would like to invite Professor Swarna Piyasiri, Dean, Faculty of Graduate Studies, to deliver the welcome address.
Actually, this is the second visit of Dr. Harin to our faculty. During his previous visit, it was on 23rd February 2011. He came to our faculty and he gave a lecture on biometrics for person identification, and it received a lot of attention from different disciplines, and there were a lot of very initiative discussions about that lecture. So that I thought he sent an email to me saying that he's coming to Sri Lanka, so I thought that it is a good thing to organize a guest lecture here on his new experience. Also, today there are members from all the faculties to gather new findings in this research area. So on behalf of the Faculty of Graduate Studies, I welcome you all to this valuable event, and also I invite you to take part in the discussion actively after the presentation as in the previous occasion. I don't want to take much time, so thank you for your participation to make this event a success. Thank you.
I cordially invite our Vice Chancellor Sir to address the audience.
Dr.Harin Sellahewa, Head Department of Applied Computing, University of Buckingham, Dean Graduate Studies. Here we have another two Deans of Faculties, Professor Surangi and Mr. Lasanta from Humanities, and colleagues and students also here, and one member from engineering faculty also participating. He is from the field of computer science. Am I correct? Biomedical, right? Okay. So, thank you very much, Dr. Harin, for visiting us again, USJP, and you have delivered your first lecture somewhere in February 2014, 11, right, at the Faculty of Management Studies. Yes. Now, we are now talking about rankings. How to score in H index. So these are the topics now we talk at the canteen here. But 5-6 years ago, we haven't discussed about internationalization or commercialization of research, those things. We are getting students from UGC and we deliver the output, that's all. But now we are in the competition. Now we are trying to get the position. How to become number one in Sri Lanka. Then how to get a chance in South Asia. So like that, we are very much concerned. So we are proud to have members like you, Dr. Harin, working abroad in quality universities in the world and frequently visiting, not Sri Lanka, Sri Java. This is what is needed for us. So I hope Dean Graduate Studies can have a program to offer visiting fellowships for foreign academics, those who are willing to come and work with us. So in future, you will be able to see such changes in our system. I don't want to take much time. This is not the time to speak. So thank you very much again, Dr. Harin, visiting here, all the way coming to USJP, and have a pleasant evening.
Again, I invite Professor Swarna Pyasiri, Dean, Faculty of Graduate Studies, to introduce the guest speaker to the audience.
Dr.Harin Sellahewa is a research lecturer and head of the Department of Applied Computing, University of Buckingham, UK. Harin holds a BSc in Information Systems and a DPhil in Computing, both from University of Buckingham. Prior to his current post at Buckingham, Harin worked as a research associate on the Secure Phone project. After completing his DPhil in wavelet-based face recognition, he moved to the Great Cancer Institute, University of Oxford, to work on optical biochips project where he developed cell counting and tracking software. Currently at Buckingham, Harin lectures at undergraduate and postgraduate levels and supervise MSc and DPhil research projects in biometrics, steganography, content-based image video retrieval and indexing. Last November 2014, he took over as the head of the applied computing. And in the past, that was in 23rd of February 2011, he gave a lecture on biometrics for person identification in our faculty. And now I invite Dr. Harin Sellahewa to deliver his present lecture on using texture features in image analysis and classification. So I invite you to do your presentation.
Professor Pyasiri said I was here in 2011. Had a really nice talk, a good discussion afterwards, and I kept in touch with a few of the faculty members afterwards. But I hope with my second visit we could do a few more things. Lots of opportunities to look at later on. So, thank you very much again for having me here for this lovely work. I'm going to talk about a few different works that I do. Some myself, some our students, and others my colleagues are involved. So I'm giving you a bit of an overview of a number of projects that we use, where we use image processing and image analysis techniques. Okay. Are you all sure that you can hear me? I'll start with a little bit of a background about my university, where I come from, and I'll give you a very brief introduction to some of the image processing tools that we are using, and then I'll talk about a number of different applications. Some are in biology, some are in security, some in forensics, and others related to agriculture. So I'm just going to touch on a few things today. Okay, so that's a map of England, and Buckingham is somewhere there. London is here. Buckingham Palace is somewhere here. So University of Buckingham is not next to the palace or near the palace. It's quite close to Oxford. That's where we are. Right. We're a unique university in UK. We started just over 40 years ago. We're still the only independent university in the UK with a royal charter. We have around 2,000 students on campus. It's only about 1,300, so a very small university. We finish our degrees in 2 years, so we don't have long summer breaks. Okay. So I'm actually on holiday, but this is my term time. I managed to cover a few lectures in advance, and I managed to get here for a short break. We have 5 schools of studies: business, law, humanities, and the most recent one being medicine. We just started this year, and the computing department belongs to science and postgraduate medicine. So these are my colleagues in the applied computing department. We are 7 members of staff, plus a KGP associate. Matthew joined us recently. I heard the Vice Chancellor talking about transferring your knowledge to industry. So KTP project is something like that. KTP is Knowledge Transfer Partnership. It's a government-funded initiative. So universities transfer knowledge to companies. So they are working on a biometric-related project. So that's myself and that's some of my colleagues. I thought I'd put the pictures there, so if you're ever interested in collaborating, doing research together, so you know who's who. Our areas of interest when it comes to research, we do a lot of things in biometrics. I talked about this last time when I was here. Other security-related things, so steganography, cryptography, video cryptography, and so on. A lot of work on image analysis, mammogram analysis for breast cancer, ultrasound image analysis for ovarian cancer and various pregnancy-related issues. I'll talk about some of those things today. Some of these work are done with our colleagues in the biochemistry. So it's not just computing, we work together with the biologists, the chemists, and so on, and other collaborating partners elsewhere. We also do quite a lot of work on wireless communication and location-based services, so particularly indoor localization. And we have a couple of mathematicians, they do stuff on mathematics. I'm myself not a mathematician, I'm an engineering science. Okay, so that's just a brief introduction to Buckingham. Right, before I start the talk, I'm just going to give one or two things about imaging because I understand there's quite a wide audience here, so some of you not know a few things. But feel free to ask me any questions. So, just image capturing process. You have a scene, you have some sort of illumination source, it reflects off the scene, you have a camera, it captures an image, there's a sensor, and then we digitize that image. So that's just a very basic way of how we capture an image and digitize it. So these individual blocks are called a pixel, and basically it has a value or intensity, and you turn that into a color. That's just very basic stuff. Right. Does anyone know what this is? Any study computing? So that's the remake of Colossus in Bletchley Park. So Colossus is one of the earliest computers ever built during World War II. It's part of breaking, not the Enigma Lawrence, I think, one of the cryptography machines. So that's one of the earliest computers. So I just want to show a histogram of an image. So histogram of an image is basically all the frequencies of occurrence of an intensity. Just shows you how many white pixels are there, how many red pixels are there, and so on. Just a histogram. So just a few basic stuff. Okay. So we use a lot of tools when it comes to analyzing images. Those who are working in this area might be familiar with a number of these things, so Fourier transforms, very old techniques, discrete cosine transforms, wavelets, and so on. So these are tools we use to extract features from digital images, and then based on these features, we can understand what's in those images. Okay. Today I'll talk about the use of local binary patterns and gray level co-occurrence matrix. I don't want to go into too much details, just know that these are tools you can use to analyze images. Okay. I hope that's okay. But feel free to ask me any questions if you need more details. Okay. So the first project that I'm going to talk about is some work I did with an MSc student in source device identification. So this is into forensics. The idea is you have an image and you want to know which device was used to capture the image. In our case, we were interested in knowing which smartphone was used to capture a given image. Right. So as you know, picture that says 1,000 words, so many different pictures, but sometimes pictures can be used for things that you shouldn't be using. For example, with the proliferation of mobile devices, people take pictures and use it for blackmail other people. People use pictures for bullying and so on. This is called happy slapping and so on, using pictures for child pornography, etc. So, in some cases, if we do find a picture like this in a forensic investigation, it could be helpful to know which camera or which mobile phone was used to capture that image. And by knowing that information, you might be able to link who the perpetrator is. So it's just a little tool that a forensic investigator would like to have. So for various reasons, we might want to know the source of an image. So given an image, did it come from a smartphone, a camera? Was it scanned from another scanner and so on? So this is the problem. So we use image features. There are different techniques to do this. We use image features to recognize the device. So if I break down the image acquisition process, we have a scene, light goes through a lens. So depending on the lens that you use, each image could have some unique features on it. Sometimes, for example, there could be some dust particles on the lens. That could create a particular signature on the image. And then once you go to the lens, there are certain color filters you use. So based on the color filter you use, that too can have certain features embedded on the picture you take. And so on. And then there are image processors, certain algorithms, proprietary algorithms, different manufacturers use. Each one of these